Math 1314, Tyler Junior College, Section 2.8, Distance, Midpoint, Circles, sketching the graph of the equation of a circle. In the previous video, we built the equation of a circle by taking the center and radius and putting it into the equation. In the second example, we weren't explicitly told the center and the radius, but we were given enough information where we could sketch a picture and use some previously learned tools to find the center and the radius of that circle. But here it's kind of in reverse. Sketch the graph of the equation, give the domain and range. Interesting. The equation is x minus 3 squared plus y plus 2 squared equals 36. Well, if we're going to draw a circle, we need to know a couple of things. Where is its center? What is its radius? Recall that when you put the center into the equation of the circle, the equation of the circle got erased. X minus h squared plus y minus k squared equals r squared. The center is h comma k. The radius is r. So, recall that when you put the center into the equation of a circle, you subtract the first coordinate from the x and you subtract the second coordinate from the k. So if we're going to remove the center from the equation of the circle, we have to answer the question, what did I subtract? So let's start by locating the x coordinate of the center. This one's pretty easy. What number is being subtracted from the x? 3. But what about the y coordinate? What number is being subtracted from the y? Well, nothing's being subtracted from the y. 2's being added to it. I know, but what's being subtracted from the y? Can't see it? Well, that's because you don't see a subtraction. Maybe you do see it, but if you don't see it, if there was supposed to be a subtraction, why is it a plus? Because it used to be minus a negative. If you're looking for what's being subtracted from something, but you see an addition, you can do a move that is not common but legitimate. You can rewrite the plus as minus a negative. Usually we rewrite minus a negative as a plus, but it's fair to go backwards. And if we did rewrite it as y minus negative 2, then the answer to what are we subtracting from the y is negative 2. Now, several of you are probably thinking, I didn't have to do all that. I knew the y coordinate was negative 2. That's great. That's great. The quickest way to pull out the center is to take out these numbers and change their signs. Hey, the 3 looks negative, but it's positive. Hey, the 2 looks positive, but it's negative. And that's captured here as well. The h looks negative, looks positive. The k looks negative, looks positive. So when you pull the center out, change the signs, because basically when you put it in, you change the signs as well. What's the radius? It's not 36. Remember, this number is the radius squared. So to get the radius, we would have to square root both sides, and if we square root r squared equals 36, we would get a radius of, not that, we'd get a radius of 6. Now, if you're really being analytical, you might be thinking, wait a minute, you said when you square both sides of an equation, you use a plus minus. Yeah, when you're solving an algebraic equation. But this variable r has a context. It's the distance between the center and any point on the circle. Distance is always positive. Radius is 6. Okay, so we have the center and the radius, but how do we use this to sketch the graph of the circle? Well, it's not really that hard. Start by finding the center. 1, 2, 3, 1, 2. So here's the center at 3, negative 2. To find the circle, go however far the radius says in 4 directions, up, down, left, and right. For example, if I went 6 units to the right of the center, 1, 2, 3, 4, 5, 6. That's the same as adding 6 to the x. And 3 plus 6 is 9. 1 point on the circle is at 9, negative 2. But what if I went to the left of center 6? Going to the left 6 is like subtracting 6 from the x. 3 minus 6 is negative 3. So if I went 6 to the left, I would be at negative 3 comma 2. Excuse me, negative 3 comma negative 2. On graph paper, this is easy. You just go 1, 2, 3, 4, 5, 6. Let's go up and down. If I go up 6 from the center, that's like adding 6 to the y-coordinate. Negative 2 plus 6 is 4, so I would go over 3 and up 4. And again, on graph paper, you can just count 6 spaces up and recount the coordinates of the points, which would be 3 comma 4. And I also need to go 6 down. Going down 6 is like subtracting 6 from the y-coordinate. Negative 2 minus 6 is negative 8. So we would have a point at 3 comma negative 8. And now that we have what I call the north, south, east, and west points, we can just connect them, make a circle. This may sound crazier, but I could draw a better circle when I draw it as 4 quarter circles. This point's a little bit too far to the left, to the right, but that's okay. All right, so to draw a circle, just go up, down, left, and right from the center, however far the radius is. Replot those points and make a circle. Oh, wait, domain and range. This is easy now that we have the graph. Domain is left to right. The leftmost point on this circle has an x-coordinate of negative 3. So our domain starts at negative 3. The rightmost point on the circle has an x of 9. So our domain ends at 9. Because both points are included, we use brackets. And by the way, this is implying that every value in between is also in the circle. It is. For example, 1 is between these two numbers. If I go over 1, there's a point up here and a point down there whose x-coordinate is 1. Can you see what the range is? Range are y-coordinates. Look at the lowest point on the circle. Its y-coordinate is negative 8. And the y-coordinate on the highest point on the circle? 4. Because this is continuous and connected, we can assume every y value in between is in the range, so our range is negative 8 to 4, both with brackets. So it's not really that hard. There are other questions we could ask, like what are the x-intercepts and what are the y-intercepts? They wouldn't be that hard to find because we have a protocol for doing that. I challenge you to try to find them, just as a reminder. To find the y-intercepts, let x equal 0 and solve. I'll tell you what they are in a second. To find the y-intercepts, I just said to find the y-intercepts, you let x equal 0 and solve. To find the x-intercepts, you let y equal 0 and solve. So, spoiler alert, I'm about to write the x and the y-intercepts. If you're up for the challenge, pause the video now, see if you can find them. But the x-intercepts, which can be found by letting y equal 0, are 3 plus or minus 4 square root of 2. Yes. And the y-intercept, which can be found by letting x equal 0, the y-intercepts are negative 2 plus or minus 3 square root of 3. If you're wondering how on earth I got those, I didn't use the quadratic formula. Way back when we discussed quadratic equations, I let one letter equal 0, figured this number out, subtracted it, and then just solved the remaining equation using square roots. Challenge yourself. You'd be surprised what you can do mentally if you try. Persevere.